So dear friends, we are going to start this microcontroller series from beginning. The earlier videos we uploaded were having some issues, so we'll start it from scratch, from fresh, and we'll try to complete the whole microcontroller series in the coming days. So first of all, the very basic thing is that what is the difference between microprocessor and microcontroller? See, in general, in computers we have microprocessors like I-core and all latest thing. But for microprocessors, what we can say that there is something called as a CPU. CPU is basically a combination of ALU and control. So here you find the ALU, arithmetic logic unit, and control unit. That forms the CPU. Okay, so control unit is somebody who can understand the instruction. ALU can perform arithmetic and logical operations. So when we say that our computer is executing a program, so actually control unit is fetching the instructions one by one, mostly from RAM or ROM. These are the areas, these are the external areas, and it is fetching the instructions in control unit. Control unit can understand the instruction and execute the instructions, and if needed, take the help of ALU. For example, you have add instruction, so control unit can understand that add instruction and ask ALU to perform the addition. So this is one chip. Okay, so for example, in older days we can have 8085, 8086, 286, 386. This is a Intel series I am just discussing, P1, P2, P3, P4, then I-core, I1, I2 and so on. So this is what one chip. Then on the motherboard you find other chips, which those are interfaced with this CPU. The chips are RAM chips. In computer, if you open the computer, you can easily see the RAM chips. There will be some ROM chips. ROM chips for permanent storage, RAM chips for temporary storage. Then I/O port. So ports, nowadays we have like USB port. In old computers you will find some parallel ports. These are communicating with the external device. For example, you connect a pen drive, so that you will connect to USB port. So these are the ports. So ports are actually some chips, and you find some interface where you can plug that device. So there is something called as a timer chips. So timer chips are needed for, you can say, time-centric operations, where we have to consider delays and all that. So these are some timer chips interfaced with your CPU on a motherboard, and there will be serial port. Actually, USB port nowadays we are using an example of serial port, but if you go in older computers, you can find there will be RS-232 type of ports. Those are what we can say is the best example of serial ports, and these are actually considered as a parallel port. So there were actually chips. Those chips are doing these functions, and all those chips were interfaced with another chip, that is your microprocessor or CPU. Okay, so this forms the motherboard. So microprocessor is something where this is one chip, and that chip is interfaced with other chips. So this becomes a complete motherboard, and that on that complete motherboard is basically when we take an example of our computer, our personal computer, we find such a type of system. But for every application, this system is not needed. For small application where we have a constraint of size, we have a constraint of memory, and so many constraints, we can go for a single chip application. That single chip is called as a microcontroller. So when you say all these components externally connected to a microprocessor, in microcontroller we find a single chip. That single chip, yes, it will be having this CPU there. Of course, CPU will be ALU plus control here. Then there will be internal RAM, internal timer, internal ROM, serial ports. We can say internal serial ports. To those serial ports we can connect on some pins actually. This forms a complete single chip solution, and in that single chip there may be inbuilt A to D converter. So we can connect the sensors directly to this chip, and that sensors will find and give us analog data that will get converted to digital. There will be parallel port, there will be serial ports. This is a complete single chip solution. So actually in this course we will be discussing on microcontroller. We will be discussing on very basic microcontroller, Intel's 8051. you can go for other microcontrollers once your concepts for 8051 are clear, because most of the concepts will remain same. Then you can go for PIC microcontroller, Renesas microcontroller, other companies microcontrollers once your 8051 is clear. So this 8051 will be a single chip that will have all this in a single chip. There will be internal RAM, internal ROM. Now why there will be RAM? RAM for temporary storage. Why there will be ROM? For a permanent code or permanent data. Why timer? Some delay type of things, we need a timer. Okay. Then for communicating with the chip, we can have parallel port, we can have serial port. For converting data from analog to digital, we have this A to D converter inside a single chip. So this is what the difference between microprocessor and microcontroller. Now in coming lectures, we'll be talking more on 8051, we'll be talking on the features of 8051, pin diagram of 8051, programming and so on. So please stay tuned to this course. We'll be completing everything of microcontroller, and that will be foundation for your career maybe in embedded systems, where in embedded system mostly we go for microcontroller. Of course there are some embedded systems which use microprocessors as well, but most of the embedded system nowadays we use microcontrollers. Thank you.